Understanding optical illusions in the brain. Optical illusions occur when our brain interprets visual information in a way that differs from reality. This happens because our brain relies on assumptions, learned patterns, and shortcuts to process the massive amount of visual data it receives. Sometimes, these shortcuts lead to misinterpretations, creating effects that deceive our perception. How the brain processes visual information. The process begins when light hits the retina in the eye, where it is converted into electrical signals. These signals are sent to the brain, which reconstructs the image based on past experiences and context. However, certain images or arrangements can confuse the brain, causing it to interpret the information in an unexpected way. The role of contrast and color in illusions. One of the most common factors in optical illusions is the manipulation of contrast and color. The brain perceives colors and contrasts relative to their surroundings, often leading to the perception of colors that aren't actually there. For example, colors can appear differently depending on the lighting or background, creating the illusion of a change in hue or brightness when no such change exists. The impact of visual context on perception. Our brains interpret objects and spaces based on context. An object's size, shape, or movement may appear altered depending on its surrounding elements. The famous Muller-Lyer illusion, where two lines of equal length appear different due to arrows at the ends, demonstrates how context can skew our perception of basic visual properties. How motion illusions trick the eye. Motion illusions occur when static images seem to move. This happens due to the way our brain interprets movement through the visual system. Certain patterns, colors, or shapes can activate the brain's motion detection mechanisms in ways that suggest motion where there is none. For example, a rotating spiral illusion can make a still image appear to spin due to subtle shifts in contrast and color. The effect of depth perception on illusions. Depth perception plays a significant role in how we see the world. When illusions manipulate this sense of depth, the brain struggles to interpret distances accurately. The Ames room, for instance, makes people or objects appear to change size due to a distorted room shape that tricks the brain into misjudging depth and perspective. Why we see unmoving objects as moving. The stroboscopic effect is a fascinating optical illusion where a stationary object appears to move when viewed in specific patterns of flashing light. This occurs because our brains are wired to detect motion in a way that fills in gaps between static images, often leading to the perception of movement even though the object remains still. The role of light and shadows in optical illusions. Shadows and lighting play a pivotal role in optical illusions, as our brains use them to determine the positioning of objects. In some illusions, light and shadow create effects where objects appear to change shape or position based on how light is perceived. For example, the shadow of a circle may make it appear as if the circle is a sphere, even though it's flat. How pattern recognition leads to illusions. Humans are highly adept at recognizing patterns and regularities in their surroundings. However, in certain visual scenarios, this tendency can lead to false conclusions. Patterns like the Kanizsa triangle trick the brain into seeing shapes or objects that aren't actually there by using gaps in visual information to form the illusion of completeness. The psychological aspect of optical illusions. Optical illusions aren't just about visual processing, they also engage cognitive and psychological factors. How we perceive illusions is influenced by attention, expectations, and mental state. People may see illusions differently based on their prior knowledge or focus, revealing the complex interaction between sensory input and brain interpretation.